this video, we are going to be discussing rationalizing the denominator when the denominator is a monomial. We are going to be talking about rationalizing the denominator. So what rationalizing the denominator means is that there is an irrational number, a square root, etc., is somewhere in the denominator. And we want to no longer have that square root in the denominator, hence rational, because rational numbers do not include square roots. We are rationalizing the denominator. So to do that, the best way to rationalize the denominator is to multiply whatever irrational number is in the denominator, because anything times a square root of 3 times the square root of 3 gives you 3, because you get a perfect square, and 3 times 3 is 9, and the square root of 9 is 3. So we can simplify or rationalize these denominators that way. But in math, you are only able to ever do two things to a expression. You can add 0. So you could add something that would create 0. So like I could always add a positive 2 and a negative 2 to anything, because plus 2 minus 2 gives me 0. And it doesn't actually affect the expression. So the other thing I can do is to multiply by 1. And to multiply by 1, I could multiply anything over itself, because anything divided by itself is 1. So on this example, I'm going to be multiplying by the square root of 3 over the square root of 3, because again, this whole thing is just 1, and anything times 1 is still itself, so I'm not changing this expression at all. But what I'm doing is I am creating this square root of 3 times the square root of 3 in my denominator, which gets rid of any kind of rational number. So when you're multiplying fractions, you multiply straight across. So I'm going to start with my denominator. We have 3 times the square root of 3 times the square root of 3. And this is going to give me 9, because the square root of 3 times the square root of 3 is 3, and 3 times 3 is 9. And in our numerator, we have 4 times root 2 times the square root of 3, which is just going to be 4 times the square root of 6. The square root of 6 can't be simplified any further. 4 divided by 9 can't be simplified any further. So this is my final answer. Example, we have a binomial divided by a monomial. It's going to again be the exact same process. One thing I do recommend doing first is always to simplify any radicals, or in just general simplify any kind of fractions that you potentially see. So let's start by changing this square root of 12. So the square root of 12, that is going to be the square root of 4 times the square root of 3. So I'm just gonna, so this is just the square root of 4 times the square root of 3. So we can rewrite this as being 2 plus 2 root 3 over 2 root 3. So on this problem, you need to be very careful that 2 root 3 in the numerator and the 2 root 3 in the denominator will not just cancel out, because that is a binomial in the numerator. So that means that the entire thing is being divided by that 2 root 3, not just that numerator term of 2 root 3. So what we can do, though, is I do see that we have 2's basically everywhere. So I could factor out a GCF in the numerator of 2, leaving me with a 1 plus the square root of 3 over 2 root 3. Now, since we have this 2 being multiplied, and this 2 right here is also being multiplied in the denominator, these 2's will cancel, because they are now factors of the entire fraction. So we can simplify it that way. So then I just need to get rid of my, or I need to rationalize. So we can rationalize by, again, multiplying the numerator and the denominator by whatever radical we want to get rid of, which in this case is the root 3. So again, I'm multiplying by the square root of 3 over the square root of 3 because that is 1, so I will not be changing this expression at all. So when multiplying our denominator out, the square root of 3 times the square root of 3 is just going to leave me with 3. And in my numerator, I actually have to distribute. So I need to take this square root of 3, multiply it by this 1, take this square root of 3, and also multiply it by the square root of 3. So I need to distribute because I'm multiplying the entire numerator. So not just that first or that second term. It's not just the square root of 3 times the square root of 3. It is the entire numerator of that 1 plus square root of 3. So doing this distribution, the 1 times the square root of 3 is just the square root of 3. And this positive root 3 times this positive root 3 gives us 3. So this is an acceptable answer. This is totally fine with leaving it as it is. If you wanted to simplify the 3 in the numerator and the 3 in the denominator, you just have to remember that you are dividing each term, so it's still going to be the square root of 3 over 3, and then 3 over 3 is 1. So these two things are equivalent. You can see for yourself which one looks a little bit nicer, and I would say the one on the left looks nicer. Though when you get to complex numbers and whatnot, you actually need to separate those terms, but we're getting more into that in another lesson. So I have a couple for you to try. So we have 4 root 5 over 5 root 10, and we have the square root of 3 minus root 6 all over the square root of 36. So take your time, try these out, and let's see how you do. All right, so on the first one, you should have gotten 2 root 2 over 5. And on the second one, hopefully you didn't start to rationalize that one without you actually trying to simplify, because the square root of 36 is just 6. So that means there is nothing to actually rationalize because that becomes a rational number. Right. If you did not get these, go back, try to find out what your mistake may have been.